Hi, welcome back to another edition of the Motions and Rhythms of the Sky. In this particular case, we are focusing in on motions that take place over a longer period of time. And so to help us out with that, we're going to work on a couple of things. And we're going to start by looking at something we've already talked about, and that is seeing all of the things that change in the sky over periods of time. So we're going to kind of work over to my desktop. And so this is something that we talked about last time. We were talking about the motion of the stars in the sky. So let me just kind of expand this so we can see this a little bit easier. And so we are looking in the northern sky, and this is the evenings this time of year. And just a quick little thing to identify. We've got up high on the top of the screen, we've got the Big Bear, or you can see the dipper portion of the bear. There's the handle part right there, and the dipper part. If you think of it as a bear, we do find the bear extending out to here. This actually, the bear is upside down. His back, his head here, and legs are actually up at the top of the screen. And this is his long, bushy tail, something that we can get into in maybe a different episode. But one of the things that you can do with the Big Dipper is the two stars that are on the outer edge can be used as a line. Just extend that line, in this case down, to this star, which is directly above north. We talked about this a little bit before last time because we watched the motion of the stars in the northern sky. That is, of course, the North Star. The North Star is positioned right above the Earth's north polar axis, and so as the stars move, that stays in the same place. And so that's the thing that we started with last time, talking about these motions, particularly thinking about the motion having to do with the nighttime. But now we're going to extend that view a little bit. So let's first of all quickly review, and we'll set the stars into motion, and you can see them starting to move. There they are, they're moving. We're going through the course of the night, and you can see they're orbiting around or rotating around this North Star. Of course, it is really the Earth's motion that's doing that. The Earth is spinning on its axis. Now, we've got a couple of things to consider with that. As the Earth, of course, is spinning around, eventually the Earth turns far enough, we're going to see the sun coming up into the sky. That means that the stars will be fading out, and although our constellation lines will remain in the sky, you can see the sky is brightening. It's now the daytime sky, the sun coming up just over on your right, and that will stay in the skies, obviously, until tomorrow night. So this is a motion that you, of course, know takes place over 24 hours. That's what a day is. But we're going to be a little fussier about that. Let's talk about that motion, because it gets a little bit tricky with the Earth also going around the sun. So we have two motions to consider, the Earth spinning on its axis, but also the Earth going around the sun. Now, we can talk about that. We can also demonstrate that in the sky. In fact, we'll go right into the nighttime hours. You can see the sun is now setting, heading down below the tree. That means that as the sky darkens, you'll see the stars coming out. And we'll pause things here for just a moment. And there we are. So we're essentially back to where we started. Now, what I want to talk about in terms of motion over longer periods of time starts with the idea of the Earth going around the sun. Of course, you know that takes a year. So let's look at what that means in the sky. And let's start on simply a daily basis. So this is the sky, and we're going to set the time so that it's a kind of a more specific time. We're just going to let time forward just a little bit, and we're going to stop at around 10 o'clock. So there it is. There's the sky. I'm looking at a time stamp that's right on the bottom here. And it doesn't have to be precise, but if I stop the time completely, so you can see the time's not advancing at all. Now what we're going to do is we're going to look at the sky exactly 24 hours from now. Again, we said the Earth spins around once every 24 hours, right? So there are the stars, and you can see the Big Dipper is up here near the top of the sky. And so we're just going to go forward exactly 24 hours. I can use my keyboard to do that. If you're using Stellarium at home, there's some great ways to try some of these things out. In this particular case, going forward one day simply means pushing the plus key. So if you do that, you'll go forward 24 hours. So I want you to watch and see what happens. And we'll specifically look at the stars of the Big Dipper. So I'll leave my pointer right there, and I'm going to go forward a day. Did you see that? There's a little change there. Let's do that again. So this is one night, and that's the next night. See, there's a little tiny shift in that. And what do you suppose that shift is about? Of course, we know that the Earth is spinning on its axis, but the Earth is also going around the sun. And what that means is that you're actually seeing the one-day motion of the Earth going around the sun. Of course, we didn't go very far, just one part of the 365 days that it takes to go around the sun once. So let's think about that. If you change that little bit each day, and let's go forward another day, you can see the stars very slowly shift each and every day. Now we're keeping the time the same, so we're just going forward day by day by day. In fact, we're now on May 10th, just as an example. So you can see we've stopped here just for a moment, and you can see that the sky has changed considerably. Let's go back to April 30th. There we are, going back and back. One more day. There we go. We're now back to April 30th. So this is the sky on April 30th at 10 o'clock at night. But you can see it changed quite a bit over a period of several days. What that means is, in order for this star to come back to the same exact spot, in other words, how long does the Earth actually take to spin on its axis? It's only 23 hours and 56 minutes. Now that sounds fussy. There's a leftover 4 minutes. Don't adjust your clocks. That's not the point. Well, I suppose in part it is. The idea here is that because the Earth is going around the sun and the sun is in the middle, that means that the Earth has to turn an extra amount to get lined up with the sun to keep the sun in the daytime sky. And so we end up with a tiny little shift in the sky worth about 4 minutes each day. Now, let's think about that. There's a quick little kind of math problem, and you can try this out. If we go forward 4 minutes each day, in other words, the sky shifts by 4 minutes each day, let's look at the Big Dipper again. And we'll do this again. We will go forward day by day. So you can see these slight shifts. There's May 1st, 2nd, 3rd, 4th, 5, 6, 7, 8, 9, 10. Okay, so the sky has shifted 10 days. Now, in that process, of course, we've also meant 4 minutes every day, or 40 minutes. In fact, if we add just a few more minutes, if we add maybe, let's say, another 1, 2, 3, 4, so we've gone forward 2 weeks, that's 28 minutes. Well, no, let's calculate my time here again. No, we've added 4, so 16. So that's 56 minutes. So one more day, 15 days, and we've shifted the sky by an hour. You see how that works? If it's 4 minutes every day, 15 days, 4 times 15 is 60 minutes. And so over about 2 weeks, 15 days, the sky changes the same as it would during 1 hour during the night. So we've got 2 motions, but you end up seeing the same change. Now, what that means is that the sky changes during the night and during the year. And that's what we're talking about today, changes that take place over longer periods of time. The northern part of the sky happens to be a very convenient place to do that. And so we'll keep track of the northern sky here. Now, first, let's move back to the last day of April. So we're going to go backwards 15 days. And we can actually speed that up. If you are using your keyboard, you can use the brackets, which are just underneath the plus and equal key. And if you go backwards, you can actually go back by 7 days or a week at a time. So I've gone back 14 days. We'll go back 1 more day. We're back to April 30th. So we've talked about the change using the idea of going forward by days, but we could demonstrate the same idea by going forward in terms of the time at night. So we're using this, we are at 11 o'clock at night. If we go forward 1 hour, and you can do that again on the keyboard by holding down the control key and pressing the plus key. So plus just advances it by the day. Control plus advances it by the hour. And so if we do that, and we'll leave my marker up here, if we do that, there's an hour. So you see, the stars have shifted actually the same amount. Are you sure? Well, let's make this very specific. So this is 1 hour. This will be 11 o'clock. But let's see if we can do that. We're going to put the cursor so that we can keep track of this spot. So this is the spot the star ended up after an hour during the night. So we're going to move it back an hour. We're not going to move the cursor. We're going to move the star field back an hour. And now we are going to go forward by day. And we're going to go forward. Again, that we said an hour was 15 days. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so you can see that's the changes that take place both during the night and because the Earth is orbiting the sun, it changes the sky during the course of a few weeks. Now that's a little tough to notice from one day to the next, but over maybe a couple of weeks, you might notice that change. And we can demonstrate that, how that changes throughout the year. And the Big Dipper is actually a great example of that, a nice way to kind of keep track of how the sky changes. So we're using the Big Dipper, and since we have gone forward in time, we're now going to advance it a little bit more quickly. And so we'll keep track of time, and here we are, we're going to go forward week by week, and that will give you a chance to see the motion. We won't go too fast in terms of time, but you can go forward. If we go forward a couple more weeks, we get to the end of May, you can see the sky has shifted. Again, that's about an hour's worth, 14 days, so just shy of an hour's worth of motion in the sky. So there's the Big Dipper. Now we are at the end of May. And if we go forward 4 more weeks, we're now toward the end of June. Now, eventually, we could see the sky change, in terms of what we can see with light in the sky. But being at 10 o'clock, that's actually a pretty good time to try this out. So there's the Big Dipper. Again, we're now near the end of June. In fact, because we're using weeks instead of months, we're actually on June 22nd, or 26th rather. So let's go forward another 4 weeks so we can get to the end of July. So there's the end of July, end of August, and the end of September. So here we are, and now we've moved along several months. Notice the change in the sky. Now the North Star, of course, that always stays in the same place. I've left my cursor up where we saw the Big Dipper back at the end of April, so we can actually see that the sky is changing in the same way that it changes at night, but now we're talking about the position in the evening, and we've left the time specifically at 10 o'clock so we can see that change. And so we'll continue to change going into the fall, or going through October, November, December. Now we're into January, February, March, April, that sounds familiar, and here we are on April 30th, and we started, remember, back on May 15th, and now we're back. So one of the things to think about in terms of the motion of the stars in the sky is that if you're viewing the sky, the stars move back to the same exact position at the same time of night on the same day every year. And that's because the Earth is going around the sun. So think about that. What that means is when the Earth is going around the sun, we are back in the same location, looking at the stars from the same place, and that's why the stars would appear in the same place in the sky. Now that's one way of thinking of it, I guess, sort of an observer's viewpoint, what you see. And that's certainly a very valid viewpoint, but it isn't physically what's actually happening. What's actually happening, of course, is the sun is orbiting the Earth. So let's think about that. If the sun is orbiting the Earth, we're going to use a different program to kind of think about that. We're going to move away from that program and use a program that I call Celestia. Well, I don't call it that. That's the name of the program. So we're now shifting our view. And in this particular view, time is kind of paused at the moment. And I've added a few things. So first of all, we are looking actually from underneath the Earth and up. Now, when I say underneath, I mean we're looking from south to north. So the way we often imagine the Earth, we're thinking about it from the South Pole. So we're looking up toward the North Pole. So here's the Earth up near the top of the screen. You can see the Earth's orbit. But the reason I mention that, if you look, we've actually added in some constellations. So viewing way out away from the Earth, you can see something called the Lesser Bear or the Little Bear, and that's the Little Dipper. And you can also see a little bit of Draco the Dragon located down in here, and Cepheus, that's King Cepheus in the sky. We don't see the Big Dipper, it's not quite lined up this way. So I wanted to mention this because, of course, as the Earth goes around, let's set the Earth into motion now. And as we do so, we'll get time moving fast enough so that we can observe it. Looks like, let's just do one more thing here. There we go. And you can see the Earth moving. You can see all of the planets moving. But one of the key things about this motion is that the stars don't move. The stars are so far away from us that no matter where we are in our orbit, they are going to appear in the same place. So our observing that we do night to night, hour to hour, or month to month, all of those time frames, the stars aren't doing the moving. We are doing the moving. And of course, we make two motions. We spin on our axis. That's why the stars change during the course of the night. And we are going around the sun. That changes the placement of the stars during the year. That was the idea when we saw the Big Dipper gradually move around the North Star during the course of the year. So let's think about that in terms of the Earth and the sun. So let's just actually, we'll kind of stop the motion here for a moment and talk about the Earth located here and the sun here. And that means the stars, which of course aren't moving, you'd be looking past the sun and you would see the sun against a starry background. Now, of course, we don't see the starry background because it's daytime, but we're going to work with that in just a moment. The other idea is that exactly opposite the sun, we'd be looking the other way. And so in this part of our orbit, when we would be looking exactly away from the sun, we would see the stars that would be in that direction. If you go forward in time, and let's pause things here again, now the Earth's in a different location. So the Earth, if you're looking toward the sun would be against a different background of stars. But of course, the night side of the Earth would be also looking in a different direction. Again, that's what we saw, that's what we observed in terms of looking at the northern sky and watching the Big Dipper change. So we're going to change our view here in Celestia. And we can do that. There are a lot of different control keys on this, so we'll let you explore that as you have time to. But for right now, we're going to change our view. Instead of looking from south to north, we're actually going to shift the sky gradually here so that we're now looking at the edge. So the Earth is in amongst all of these planets, and the planets all orbit the sun at about the same level. But here's what I want you to notice. If you look in the background here, we see actually this is Taurus the Bull, located right here. And so if we start time advancing once again, of course, we don't see any change because we're looking in the same direction and the Earth is going around. But if we think about the Earth changing its location, if we were to move around our viewpoint, so in other words, we're going to change, instead of looking, say, from the Earth toward the sun, and with we have Taurus the Bull in the background, we're actually going to see a change here. We're going to shift our view. And you can see Taurus is now sliding over this way. And now we have some different constellations coming into view. In fact, down here, just below, we have the twin stars known as Gemini. And if we keep changing our position, we see the crab, sometimes called Cancer, the crab. And I'm just going to adjust our view so we can get as close to being edge on as possible. So there's the crab, and we'll keep changing here. We'll keep shifting. Now we see the lion, who is Leo the lion. And then we have the Virgin, Virgo, followed by the scales. You can see the scales right here. And that moves on to the Scorpion. You can see the Scorpion. And that continues into Sagittarius. And then Capricorn, or the goatfish. And you can see, so we're changing, but these names, the goatfish is also known as Capricorn, for example. We have the fish, that's Pisces. We have the ram, that would be Aries. Are those names familiar? Oh, and we're back to the bull again, Taurus, the bull. So those names, those are known as the horoscope signs, or the zodiac constellations. And those are all lined up with these paths or these orbits. If the Earth is looking toward the sun would be against those starry backgrounds. So this is one way to imagine it. I have yet another way to imagine it. So we're just going to let that disappear here for a second. And we'll kind of give you an overview by looking at this particular image. So here you can see, with the Earth located here in June, the starry background behind the sun features Taurus the bull. As the Earth moves, the Earth is going around the sun. By August, the sun is now against the background of the stars of Cancer the crab. And so as the Earth goes around the sun, it changes the background. So those are what we know as the horoscope or zodiac constellations. And of course, they have particular dates associated with them. So let's actually try that out. We'll use our program Stellarium to give you another example of being able to see that. And this changes our viewpoint a little bit. So we're now bringing up the program Stellarium here, and we were looking in the north. So now that we've returned to May 15th, so we're in the middle of May here, we are going to shift our view. We're going to look a little bit more over to the west. And you can see some of the constellations that we mentioned. We can see two stars here. Those are the twins of Gemini. This is Cancer the crab. Up higher is Leo the lion. Now, we were looking at the sky the way it appears at 10 o'clock at night. So let's change that so that we can see the sun during the daytime sky. So to do that, we're going to change our position. We're going to look toward the south. And we're going to go through the entire night. We'll let the night progress here. It's always fun to watch the stars work their way across the sky. You can see the stars, instead of spinning around like they do in the north, the stars are, of course, moving from east over to west. And some of the other constellations that we mentioned, there's Virgo, the Virgin. There are the scales, Libra. Scorpio, the Scorpion is here. That is Sagittarius. Here's Capricorn, the goatfish, and there comes the sun. Now I'm going to let the sun continue up into the sky here so that we can see it, and I'll leave the constellation lines up, and we get a chance to see, there's the sun, and you can see it where it would be against the starry background. Of course we can't see that, but the program Stellarium actually allows you to see where the sun is located against the background of stars. First of all, let's pause the motion with the sun in the south, and we're going to change our view. In this case, we can actually eliminate the atmosphere. The letter A actually does that very nicely. If you just hit the A, you can see the atmosphere has disappeared. The ground is still bright because it is daytime, but notice the sun against the background of stars. And so this is where we see it, and here we are in the middle of May. So again, if we leave the time the same, and we're close to the midday hour, it's actually 12:30, and we'll stop time. If the sun is located here in the middle of May, if we go forward in time, and we can do that again day by day by using the plus key, and as we do so, notice the background of stars is shifting. The sun is staying more or less in the same place, but notice the stars are shifting so that by the end of May, here's actually it's the very first day of June, the sun is right in the stars of Taurus, the bull. And one more change, of course, you know, the sun does change during the course of the year. So if I leave my cursor where the sun is and we go forward into June, during June, the sun is shifting from Taurus the bull into the twins of Gemini. But let's look and see one of the other things that changes in terms of the sun. You see any change in the sun? Remember, I've left my cursor in the same spot, but the sun is a bit higher in the sky. Of course, the sun gets to its highest point on June 21st, the first day of summer, the summer solstice, and you can see the sun is also getting over close to the twins. Now, we were going forward day by day. If we just simply hold down the plus key and let time progress, you can see a smoother change. The sun has moved through Leo the lion. Now it is into Virgo. The sun dropped much lower in the sky. In fact, this is the 1st of October. So there's another change. It's not exactly the motion of the sun, but it is a change in terms of where we see it in the sky. Of course, you know, as we get into the fall, the sun gets lower in the sky. In fact, we'll let it continue here. We'll advance all the way to the first day of winter when the sun is at its lowest point in the sky. And a little bit farther along here, there we go. Notice the sun is now between the constellations Scorpio, the Scorpion, and Sagittarius. Sometimes this is known as the teapot in Sagittarius, but this would be the sun at its lowest point in the sky. All of this having to do with the motion of the Earth going around the sun, and of course the Earth has an tilted axis. It isn't straight up and down. We talked about this last time, that the sun changes its position in the sky because the Earth's axis is always at the same angle, but we are moving around the sun. So these are motions that take place over longer periods of time. We've been able to use the stars. We can see how the stars change, spinning around in the north, around that North Star, the Big Dipper changing, of course, during the course of the night as the Earth spins on its axis, but also changing as the Earth goes around the sun. It makes the same motion, but it takes place very slowly. Remember, it's just a change of about 4 minutes per day, but it slowly shifts that. So there's a little math problem, a little challenge you can try out. If it changes 4 minutes per day, add that up over the entire year. Essentially, if you multiply 365 times 4, see what you come up with for a number. It might not be exactly 24 hours. We'll talk about that on a later issue, on a later program, but it's certainly worth trying out the math just to see what you can find out about that. So again, we've reviewed the motions over long periods of time. We've now seen the sun change over the course of weeks and months. We've seen the stars change over weeks and months as well. So one of the things that would be interesting for you to do, and we'll give you kind of a little assignment here, you can try this out. We've shown you just briefly where the sun is located against the background of stars at different times. Since Stellarium can give you the exact time and show you the background of stars, find out if the sun's location against these backgrounds matches up with a horoscope. You can find the horoscope online most anywhere. You can also find it in the newspaper. There are some printed publications. So find out where the sun is, let's say, as we go into May and June. You can find out where it is actually in the sky, and what does it say on the horoscope in terms of the time that is supposed to be. Now, we'll talk a little bit about that next time, because One of the things that is also changing is the Earth's axis changes not just during the course of the year, it actually changes over long periods of time, thousands of years. This affects where the stars are positioned, it affects where the sun is positioned in the sky, and it's something that's been known for thousands of years, discovered in Greece over 2,000 years ago. So we'll explore that idea next time on the movements and rhythms